Earth is a terrible place for launching rockets. It has thick air, strong gravity, and it takes huge amounts of fuel just to leave. But there is a much better place, and it's only 3 days away. Today we're talking about why we're going back to the moon and how it could become humanity's first base in space. We'll look at how the moon is trying to kill you, how the water hiding in darkness will change everything, and why launching from the moon is way easier than launching from Earth. I'll even show you. But now comes the big question. Why go back at all? It's because now we don't want to just visit the moon, we want to have a permanent presence on the surface. You know, a moon base. That means living there for weeks or months, building habitats, generating electricity, recycling air and water. Basically, learning how to survive somewhere that is completely different than Earth. And the moon, it's perfect for that because it's pretty close, it's easy-ish to resupply, and if something goes wrong, we can make it back to Earth. It's a baby step on our way to explore the universe. But let's be clear, the moon is trying to kill you. It doesn't have an atmosphere, which means there's no air to breathe, there's no air pressure, and there's nothing to stop the radiation of the sun, like our air does here on Earth. The temperatures, they swing wildly. Even though the Earth and the moon are about the same distance from the sun, the day side of the moon, where it's sunny, is 250 degrees Fahrenheit. And then if you go to the night side, where it's dark, it's negative 280 degrees. And that's a swing of over 500 degrees Fahrenheit. 250, negative 280, 250, negative 280. It really makes you appreciate our atmosphere even more. So where would you even build a base on the moon if you could, given that it's so incredibly inhospitable? Well, this is where things get interesting. Near the moon's south pole, there are craters that never see sunlight. They are permanently shadowed, which means they're incredibly cold and they have been for a long time. And inside those shadows, scientists believe there is water ice. And water changes everything, because water isn't just for drinking. It can be broken apart into hydrogen that we can use for fuel and oxygen that we can use to breathe. So suddenly, the moon isn't just a place we visit, it becomes a place that can support human life and exploration. And now here's the part that really changes the game, because launching a rocket from Earth is really difficult to do. We've got a lot of gravity, we've got really thick air that wants to tear rockets apart, and we have to carry all of our fuel with us. Now let me show you what I mean. On Earth, most of a rocket is fuel, fully loaded and really heavy. On the moon, you would need just a fraction of that fuel, because the moon's gravity is 1/6 of Earth's and there's no atmosphere to slow you down, which means less fuel, lighter rockets, and a much easier launch. It's like these two film canisters. I'll share how this is done at the end of the video, and I'll explain what a film canister is for you kids. One I've loaded down with weights to represent a launch from Earth, and the other, it's like a launch from the moon. And when they launch, you can see just how much easier it would be from a moon base. I mean, Earth is like trying to jump out of a pool, and the moon's more like stepping off of a curb. It's a classic case of Newton's second law of motion. Am I right, people? And Newton's second law of motion is stating the obvious in a scientific way. It basically says that if you push the same on two objects, the lighter one will accelerate faster. Or if you push on two identical objects, the bigger force or pusher will accelerate faster, which explains a lot about how rockets launch. And this is the big idea. If you can live on the moon, make fuel on the moon, and launch from the moon, then suddenly going to Mars gets a lot easier. Asteroids become reachable, and deep space becomes possible. Because the moon isn't the destination, now it's a launch pad to the future. A place to learn, to build, and to take the next step into our exploration of the universe. And speaking of the rest of the solar system, what if I were to tell you that the most interesting places in the solar system aren't even the planets? And that's what's in our next episode. So until then, stay curious. Now, to make a film canister rocket at home, you need eye protection, water, Alka-Seltzer, and a film canister. Simply add Alka-Seltzer to the film canister, and you can experiment with different amounts. Fill up the canister halfway with water, and then snap the top on and place it on a solid surface, top down. Back up and enjoy. The reaction between the tablet and the water creates carbon dioxide gas, the pressure builds, and it launches. And to keep kids busy for longer, have them turn the canister into an actual rocket-looking object, or explore with different amounts of Alka-Seltzer and water. All of these little changes are science in action. And what is a film canister? Well, traditional cameras used film, sensitive to light. Film canisters held a used film cartridge in total darkness to preserve the film quality before development into photos. Digital cameras are so much easier.